this video. Now in this video we're going to take a very big look at atoms. We're going to look at how atoms are formed, how we consider atoms to be the building blocks of any element or any matter on earth, and why they are so important. So now in our schools we've learned that atoms are made up of protons, neutrons, and electrons. Okay, and we have been given definitions that sometimes we hardly can remember, but I want to give a definition that is very easy to remember. Let's define atoms as the smallest part of any matter on earth, like the smallest part that has chemical properties in it, and we consider that to be an atom. Let's imagine that we have this object here. The smallest part of this object that you can take away from it, and that smallest part will still have some chemical properties, then we can consider that part to be an atom. The smallest part of that object that can have chemical properties. Now, if we cannot get anything that has to do with chemical properties from that little piece of matter, it means that we cannot consider that to be an atom. Why is that important? It is important that there should be some properties that we can get from such a piece, because we need to know the kind of charge and the type of atoms, the types of element that that atom is going to form. We need to know the amount of protons, electrons, neutrons, so that we can really determine what category of element that atom is. So simply, an atom is the smallest part of a matter or of an object, but that smallest part must have traceable chemical properties in it for it to be considered atom. Okay, now let's look at how atoms are formed. Now, an atom has normally a center, what we call a nucleus. In this diagram, we see a representation of the center or the middle of this atom, okay, that we're going to form right now. So we have a nucleus and we have an orbit or a shell. So as small as that object must have a center, a nucleus, and it must have a shell. Now, in this center or the nucleus lies the protons. Now, protons always lie in the center of the atom. In other words, if I take a proton this way and I place it here, the proton is going to stay in the middle. But electrons do not stay in the middle. Look at, if I try to pull this electron and put it in the middle, it goes on to stay around the shell. Okay, so why protons love the nucleus of the atom, and the same thing with neutrons, they like to stay in the middle. Electrons do not love to stay in the middle. Okay, now what makes up an atom? An atom is made up of three parts, three particles: the proton, the neutrons, and the electrons. Now, one thing we must know is that the number of protons in an atom will determine what type of element that proton is in our periodic table. So, if I have just one proton, it means that we are talking about hydrogen. If I have two protons, it definitely means that we are talking about helium on the right side of the periodic table. So you can see that electrons do not really determine what element we have in front of us. Instead, it is only proton that determines what element we have in front of us. But what electrons do is to give a charge to such an ion or an atom. Electrons will determine if an atom or an ion is negatively charged or positively charged. So I repeat, the protons determine what type of element we are dealing with, but electrons only determine the charge. Okay, now another concept that we must not forget is if I have one proton here, I have a positive ion. It's no longer an atom. But if I have an electron, it becomes an atom, but a neutral atom because we have one positive charge and one negative charge. So they kind of like compensate each other, and we have a neutral atom. Now, what happens if I should add one proton to this my atom? I have a positive ion. Why? Because I have more of the positive charge than my negative charge. And what happens if I add one electron? I'm going to have a neutral atom because the two positive charges balance up with the two negative charges. Now, have you noticed how we change from atom to ion? Look at, if I take away one electron, I have an ion. So what does that tell us? It tells us that an ion is a charged atom. An ion is a charged atom. But when we have a neutral atom, we can no longer call it an ion because it is neutral. So an atom becomes an ion when that atom is charged. It could be positively charged or negatively charged. So let us get the concept. So if I wanted a negative ion, all I have to do is to add more of the electrons and it becomes negative. And if I wanted a positive ion, all I needed to do was to add more of the positive. But we must know that as long as I keep adding my positive protons to my ion or to my atom, then the element is going to change, and so is the chemical property going to change. So if you want to keep using an element like hydrogen, you must make sure that your proton is 1. You can joke around with your neutron, it still remains hydrogen. You can joke around with your electron, it still remains a negatively charged hydrogen ion. But you cannot play with your proton because the proton determines what type of element that you have. So with this little concept, I hope that we have gotten a very solid take on what an atom is. Okay, now there is another concept that I want to teach you. Look at this. From the beginning, I said that the protons always like to stay in the middle of an atom. They stick to the nucleus. And if I put an electron, it's going to stick around the orbit. If I put another electron, it's going to stick around the orbit. Now, if you notice, they always maintain a 180 distance away from each other. And the inner shell is always occupied by maximum 2 electrons. So if I keep adding electrons to my ion or to my atom, you see that every single electrons that I add is going to occupy the external shell, and we can get a maximum of 8 in every shell. 1, 2, 3, 4, 5, 6, 7, 8. So the inner shell always takes 2, while the outer shell can take 2, 4, 8, as the case may be. But maximum number of electrons that a shell can take is 8. So what happens if I take away this proton from this ion or from this atom? If I take away this proton, then we don't know what this atom is. We don't know the element, because there is nothing like positive charge. So it means that positive charge really tells us what type of element that we're dealing with. Mind you, neutrons do not really play any major role. You can add as many neutrons as you like, nothing will change. The element will not change, the charge will not change. So guys, so this is the big difference. So to recap, an atom is the smallest part of an element or of a matter with traceable chemical properties. Protons determine what type of element we have. The more protons we have, the more element we're going to have based on how they have been placed in a periodic table. Hydrogen has just one proton, so it is the first element. As you increase your proton, you go from first, second, third, fourth element in the periodic table. Now, when an atom is charged, we call it an ion. When the atom is not charged, we call it atom. But when it is charged, we call it an ion. It can be positively charged or negatively charged. Neutrons do not really play a significant role in our atom, and electrons play the role of being a charger. Let's use that word. So it is the amount of electrons that will determine the charge of my atom. If I have more electrons than protons, then my atom is negatively charged. And if I have more protons than electrons, my atom is positively charged. So I hope this concept is clear, and I'll see you guys in the next video.